Alright guys, welcome to 7.2's video presentation of properties of parallelograms. And in this section we're talking about all things parallelogrammal, and that includes the definition of a p-gram, which I like to refer to them, p-grams. Save some syllables. The definition is you've got opposite sides parallel. So parallel, parallel, definition, parallelogram. Now there are some theorems that ensue as a result of that, and the first one is that their opposite sides are also congruent. So not only do you have the arrows, you got the slashes, single slash, double slash, double slash. So it's kind of like a rectangle that got sat on, and now it's tilted. The opposite sides are still congruent and parallel. All right. Also, you have the opposite angles being congruent, the ones across from each other. That's an important one. So two very important theorems regarding parallelograms, or p-grams. All right, now, back in chapter 5, we did a lot of work with congruent triangles, and it relates very nicely here to how we would actually prove the theorem that says the opposite sides are congruent. Now check this out. We draw a diagonal in QS into this parallelogram, and that's going to help us, because if we can show these two triangles are congruent, then we can say their opposite sides are congruent by CP/CTC. So what we know so far is it's a p-gram. So we've got opposite sides parallel. All right, that's given. We can always slash the middle reflexive. We have alternate interior thanks to those parallel lines. That gives us angle side angle triangle congruence. And then of course we can go CP/CTC. So here it is written out. You can pause it. Alternate interior, reflexive ASA, CP/CTC. So even though we won't have any proofs on the next quiz, it is nice to look back and see how we would use all these things that we talked about before to show a theorem that we just learned. All right, now, here are the main questions from this section. The first one, using the properties of the p-grams, we've got the opposite sides being congruent, so I can just simply set x plus 4 equal to 12. And then the opposite angles are congruent, so I can set y equal to 65. Subtract 4 on both sides. X is 8, y is 65, and that is a great example of how you can use the properties of parallelogram. Two more theorems coming at you. Consecutive angles are supplementary, so the ones that are next to each other will add up to 180, and the diagonals will bisect each other. So they're not congruent. So like QS doesn't have to be the same length as PR, but they will cut each other in half, so that QM is the same as MS, and PM is the same as MR. All right, let's use some more properties. Parallelogram PQRS. So if there is no picture, you're going to have to draw one. All right, no problem. And when you label it, just make sure you go in order of how the letters are. So P, Q, R, S. You could start P up here or over here or here, as long as you go in order how the letters are written. So they give you information about P and about Q. So you know that since they're next to each other, they're going to add up to 180. P is 4 times Q. So you want the smaller one, which would be Q in this case, to be your variable. And then you can put P in terms of that. So P is 4 times that. If you would put the X where P is, then you'd have 1/4 X for Q, and you don't want to deal with fractions. So once you establish what P and Q are, go ahead and do what the theorem tells you. Set them equal to 180. And solve it out to get X is 36. Once you have that, they're looking for the measure of angle P. So the measure of angle P would be 4 times 36, or 144. All right, another cool question. Example 4. Using p-grams in the coordinate plane. Find the coordinates of the intersection of the diagonals. So as soon as you see intersection of the diagonals, think about what that means. The diagonals, of course, are the lines going from corner to corner. And where they meet, since the theorem told us that they bisect each other, that is going to be the midpoint. And so all you have to do is find the midpoint of one of the diagonals. How do you know which one's a diagonal? Look at how the letters are written. L and N would be a diagonal, because if you wrote it out, they would be across from each other. Or M and O. So we can find the midpoint of either one of those. It'd be the same thing. So I'm just going to go LN's midpoint. So L and N. So add the x's up, divide by 2. Add the y's up, divide by 2. 7 halves, comma 2. Maybe the book will want 3.5. Either way, fine by me. All right, pause the video here. Try the extra example 4. All right, back again. Hopefully you got 3, comma 1.5 or 3 halves. Midpoint between AC or BD. Either one will get you there. Last example today is we can actually use the properties of parallelograms to find a fourth coordinate if we're given 3 points of the parallelogram. So in this case, we're given W, X, and Z. We want to find the missing Y. So go ahead and sketch out an XY axis and plot the 3 points that are given. So W is at -1, and you're just obviously approximating here. So -1, -3, there's your W. X is at -3, comma 2, so it'll be over here somewhere. That's X. And then Z is at 1, 2, 3, 4, 1, 2, 3, 4. 4, -4. So now think about what we're dealing with here now then. We've got that situation. So the fourth point is going to be over here somewhere to make this thing a parallelogram. So now the properties tell us that the opposite sides are parallel, so it'd have to have the same slope. So however I got from here to here, I can just replicate that on this side, and that'll tell me where to end up. So how did I go from W to X? Well, I went up from -3 to +2, so that's 5. And then I went to the left from -1 to -3, so that's a shift of 2. So just do the same thing here. Go up 5 and go over 2. That's going to put you at, if you add 5 to the -4, that's at 1. And if you go 2 to the left from 4, that's a +2. So there's the missing coordinate. All right, pause the video and try the last one you have right here. All right, welcome back. Let's see what this one looks like. Sketch it out. So -1, 4, there's our first coordinate. That's D. 2, 3. 2, 3, that's E. And then F is at 4, -2. So down here somewhere. All right, so that's what I got going on. Got to find that last point. So now, let's see, look between any of the two of the points that you have. So for instance, I can go from this one to this one, and got to do that same thing. Let's see, where's that going to take me? All right, well, what did my Y's do? I went up 1 in this case. So I should go up 1 from down here. And then I went, let's see, from 2 to -3 is over 3. So go over 3, up 1. Over 3 would take me to 1. Up 1 would take me to -1. So there should be your answer, 1, -1. All right, guys, that's a wrap on 7-2. Peace!